Alright, so we got one here in the hot pocket. That little trap over there, what I like to call the hot pocket. Because we got Mr. Heater here putting some heat down on this thing, so we got about 173 degrees, which is a little bit lower than what it could get up to in the bus on a hot summer day. As you can see, we're spinning it with that electric motor. And so what we're gonna do now is show the testing. So this is our power supply. We're running a little bit less than charging system voltage, about 27 volts. You can see we're drawing about 1.648 amps and 44.4446 watts. You'll see it dancing around a little bit because we're applying so much heat that it will change the resistance of the coil. And the idea is to make sure that the coil doesn't short out or something under load or go open under load. So right there we're in high speed. Okay, we're gonna go switch it to off. And you see how nice and quickly it stops. That's because we got nice new seals in the gearbox. It's got its gear oil in there, but you're gonna get a high performance red line oil. What's in there right now is test oil. So I'm gonna drain my test oil, and that also allows me to get any little debris that may have been missed inside out with that oil being warmed up as it is here. All right, so now that we're up to temperature, we can go ahead and dial the heat back a little bit. Okay, and then we slowly warm it up. Okay, so we take our time, we let it start to just spin up, warm up the bearings first, and then just let it run on its own with no heat for a while until it's up to about 145 or so, and then we start to apply this heat. So we're heating it gradually, and then we'll also cool it gradually so as not to shock the case or the seals or anything like that. All right, now let's go ahead, and this is what's really important here, is that it's able to stop when you switch to low speed. All right, or when you switch to off, excuse me. So off is in the middle there. So now let's go ahead and go to low speed, which will be down. Okay, so there's off again. You see that we can stop, which is important. That is a function that the ECM needs to be able to control. Need to be able to achieve off when there's no need for the fan. This way we can get optimum temperatures for the engine and the after treatment system. All right, so let's go low speed. All right, and now we're gonna go up to high speed up at the top here, and you can see this gap disappear. That is courtesy and torque to specification, as well as the front bolts, all the bolts inside, everything you can see the torque seal. Okay, our connectors, serial number is made on it as well. Connector for everything is the same as it was. I'll show you guys that connector from underneath once I completely shut off the heater. Alright, it's kind of hot on that side. You can see there's no leakage. Okay, so what we're looking for is anything out of the ordinary. Okay, so make sure there's no leak, there's nothing even seeping. Okay, it's very important to us that we put out a quality product for you guys. So the other test I would like to show, we need to shut it down, but before we do that, let's go ahead and go over the numbers. So the coil serial is 336051, and the gear case serial is 024625. All right. So, and then we have our company serial engraved on the inside as well. So all these parts are serialized together. I just want to make sure that we're clear on that. Do not disassemble the unit, because that will void the warranty completely and instantly. Okay, so let's switch it to off there. We'll switch it to off here. And now that there's no power flowing through the jig here to the fan clutch, we can go ahead and make sure our leads are properly set up for ohms, which they are. And then we'll switch that on to ohms. And now we're checking the hot ohm reading. Okay, so normally we're at about like 38 to 42, depending on the coil, but this is a much newer coil, and I realize that sometimes these coils have lower resistance than the older style ones. So this is a good stable ohm reading at a hot temperature here. I'm happy with that. We should drop down a little bit as it cools, because the resistance will get less as there's less heat in the windings of the coil. Okay, so now let's go ahead and switch over. So that's our low speed. And then our high speed, usually in the teens. Yeah, there we go. So 16.3. When it's cold, you can see that resistance go down a little bit to like 13, 14 ohms, which is normal for these coils. So you can see it's pretty stable with almost 170 degrees in it. So we can go ahead and start the slow cooling, and we can show you the connector underneath now. So we're in low speed. We always start off in low speed so we don't shock it into motion, shock that high speed spring, right? Okay, so now we're gonna go ahead and go high speed. Just get some oil circulating in there, and we'll shut down the heater. Okay. And now we can go ahead and take a look at the connector. You can see the setup, transfer seat all the way around it. I got that little fan keeping my electric motor cool, but this little hot pocket allows the heat to travel all around the fan clutch, so we have a better chance of evenly heating it up. The other thing is, I like to grab my lights. Bear with me for a second. Sorry about that. Got my light. You can see that everything here is torque sealed. The emergency bolts are screwed in right here. So you may have to remove those and put them on the bracket that's on the bus. So that way they're accessible when you install them in the bus with the heat shield there. Yeah, it looks good. No leakage, no seepage, nothing. Very nice and clean underneath. Don't hit your finger on it. It doesn't feel very nice. But it happens all the time around here trying to get this good footage for you guys. But yep, looks good. Let's take a look at the connector. It's in good shape. Nothing broken, nothing cracked. It's epoxy on top. You guys can see that. We epoxy them to keep them more stable, and it prevents, if there's ever oil seepage, it prevents oil from going inside of the connector. So that's a great thing that we do, and it also keeps it more stable. Okay, we're connected. The threads have all been checked right here, been run through with a tap. Same thing on the front. Obviously that's being held on. The main bolts are torqued over 150 foot-pounds with Loctite. All the threads of the case were verified as good and usable. There may be small cosmetic blemishes, but nothing that affects the use or any of the threads holding torque or anything like that, because these are remanufactured units, but they have just a great value. We have a lot of junk ones that we can't use that we get back as cores, so that helps us, be able to replace certain parts that are good. If you have a failed unit, we can take from our stock and replace and be able to make you a good unit like this one. So this is a really nice one here. All right, so now let's go ahead and shut it down. Okay. Spin down's nice. Okay. Let's go ahead and shut off the motor. Okay. That click is from this. It's the low speed resetting the startup. Okay, if you look in there, you can see our torque seal on the main bolt. Like I said, everything torqued up to specification and marked specifically to be able to ensure that no one takes apart our units. We know some customers just would not do it, but we've had it happen in the past where people decide to take them apart and try to weasel one together and say, hey, this thing's making noise, and then it turns out that it's not even ours. The gear case is ours, but the clutch is a used one from another bus. So yeah, let's please not have any of that. It's that never ends well. But this is a good unit, ready to pack up and ship out. And it's going to be delivered to Cardiff Limousine in Palm Desert. Thank you for watching. Thank you for purchasing. We appreciate you guys very much. Without the customers, we wouldn't be able to do what we do here. And God bless you all.